Hey everyone, in this video we're going to discuss about minimum spanning trees. So I'm going to explain this topic minimum spanning trees with the help of an example. So let's take a look at this. So observe that I have drawn a graph here, a very simple graph, and let's suppose I say that this graph is G, and we know that graph is a set of vertices and edges. The vertices of this graph are 1, 2, 3 and 4. So I'm going to write here V is equals to 1, 2, 3 and 4, where V represents the vertices. So now there are edges in this graph which you can observe, and to write edges in the form of a set, I will write it like this. 1, 2 is a single edge, then 2, 3, then 3, 4, and so on. So these are the vertices and edges of this graph G. One more important point to note here is that this graph has a cycle. And a cycle means that if you start from any vertex and you travel through the edges, you will be able to reach at that vertex. So we also observed that there is a 1 cycle. So I'm going to write here 1. So this is a graph G, and I want to make a graph S with some vertices and edges, and this graph S will be the minimum spanning tree of graph G. So in order to make a minimum spanning tree, the basic idea behind is that the number of vertices will be same in this minimum spanning tree, whereas the number of edges will be the number of edges in the original graph minus 1. So let me write it here. So number of vertices in the minimum spanning tree will be equal to V, which is this one. So I'm going to draw here a minimum spanning tree which has the same number of vertices. And basically a minimum spanning tree is a subset of this graph G or any graph G. But the subset is not of both vertices and edges. The subset is only of the edges. So in edges, which is E dash, and E dash represents the edges of the minimum spanning tree, I will write V mod minus 1. V mod means the number of vertices. Now number of vertices, or N, is equal to 4 here. So we have 4 vertices here. So the number of edges in the minimum spanning tree should be 4 minus 1, which is equal to 3. So in order to construct a minimum spanning tree of any given graph, these are the requirements. The number of vertices will be the same, whereas the number of edges will be the number of vertices minus 1. That's a very basic concept. So now, if I want to construct a minimum spanning tree with 3 edges, I can do something like this. So this is one of the possible ways to create a minimum spanning tree, and you can see that I have removed this edge here. Similarly, someone can say that what if I don't want to remove this edge, but instead I can also remove this edge. This will also be a minimum spanning tree. So there will be some combinations of minimum spanning tree, and we are now going to see that. So the question is the number of minimum spanning trees. I'm going to write here MST, the number of minimum spanning trees of a given graph G is equal to, so we want to find out how many minimum spanning trees will be there. So let's find out the number of minimum spanning trees for this particular graph and then we will be able to formulate a particular or a general case for all the graphs. So in this case, we have 4C3 combinations. 4 is the number of vertices in this graph, and we want to make a combination of 3 of them. So 4C3 will give us the number of minimum spanning trees of this given particular graph G. 4C3 will be equal to 4. So there are 4 minimum spanning trees of this graph G. Alright, so it also makes sense because if you remove this edge, you will obtain 1 minimum spanning tree. If you remove this, you will get 2, then 3 and then 4. So there are 4 minimum spanning trees. And since it has one cycle, I will write here that the number of minimum spanning trees is 4 in this case. So let me just draw another graph and let's see what will be the number of minimum spanning trees of that graph. So let's suppose I add another vertex here. So now I'm going to add another vertex here, which is vertex 5, and I'm going to join it like this. Now in this graph G, the number of vertices is equals to 5. The number of edges is 1, 2, 3, 4, 5 and 6. So the number of edges is equals to 6. And we know that if we want to create another spanning tree of this graph, we will have to make the number of vertices equal. So V dash will be equal to V. So you can see that I have created 5 vertices here. But the number of edges will be equal to the number of vertices minus 1. Now in this case, the number of vertex has changed to 5. So 5 minus 1 gives me 4. So the number of edges in this graph will be 4. So you can see that 1, 2, 3, 4 are 4 edges in this graph. And one thing that you should always remember is that the graph obtained should be a connected graph. You cannot remove this edge like this because this will make this graph disconnected. So it will have to be a connected graph. Now we can see here, the combinations will now be more. So we will obtain some more number of minimum spanning trees. So what is the number of minimum spanning trees in this case? Initially the number of edges was 6. So 6, see, there are 6 edges and now we have only 4 edges left here. So I'm going to write here 6C4. So 6C4 will be able to give me the number of ways. 6C4 is equals to 6 factorial upon 4 factorial into 2 factorial, which will further give me 15 as an answer. So there can be 15 number of combinations in these minimum spanning trees. One important point to note about minimum spanning trees is that a minimum spanning tree should not contain a cycle. You can see that in this minimum spanning tree there are no cycles. So if I would not have removed 2 edges, I would have removed only 1 edge, there will be a cycle here. So that's why we need to remove these cycles from the minimum spanning tree. So we will not consider those minimum spanning trees which have cycles in it. So the general formula for calculating the number of minimum spanning trees of a given graph G is equals to the number of edges that were originally present in this graph, C, which is the number of combinations, and this is actually equal to E dash, which is mod of V minus 1. And now since we will also have to remove the number of cycles, so if there is this edge, there will be 1 cycle, and if I will consider this edge there will be one cycle. So I will have to remove these two cycles. So what I'm going to do here is I'm not going to consider two minimum spanning trees. So in this way we can obtain the number of minimum spanning trees of a given graph using this formula, where 2 is the number of cycles in graph G. In the original graph G there were 2 cycles. So this is what our minimum spanning tree is. So now let's take a look at minimum cost spanning tree. So I'm going to write here minimum cost spanning tree. Alright, so let's take an example of a minimum cost spanning tree. Now let's suppose we have a graph like this, but now we are going to consider a weighted graph. A weighted graph, and a weighted graph is a graph in which the edges have some values. So let's say the values of these edges are 7, 3, 5 and 6. So these are the weights of this graph G. So let's suppose the edge represents the distance between two locations. So 7 means there is a 7, let's say, kilometers between distance between these two locations. So let's construct some minimum spanning trees of this weighted graph. So now let's say I will remove this edge, so I will get a minimum spanning tree like this. So if I calculate the distance of all these graphs, and since this is a minimum cost spanning tree, let's say that it takes $7. Let's say it takes $7 to reach from 1 to 2, and similarly $3 to reach from second location to the third location. So what will be the cost, the total cost of this graph, which is graph G? It is 7 plus 3, 10, then 15, 6, 21. So 21 is the total cost of this graph. What about this minimum spanning tree? It will be 14. Let's consider another spanning tree, which is like this, and I will assign the values here. Now what is the total cost in this case? In this case it will be 15. Again I can construct one more, which will look something like this. So now I will assign the cost 7, 6 and 5. What will be the total cost? 6 plus 5 is 11 and it will be 18. Now there is also the last one, the last case will be like this. Again we will assign the cost 7, 3 and 6, and we will calculate the total cost, which is 16, 18, 15 and 14. So the minimum cost in this case is 14. So let's suppose we want to calculate the cost of travel between any two positions, and we want a minimum cost. In that type of algorithm, we need an algorithm for that too. And the algorithm that we are going to discuss for the minimum spanning tree, there are two algorithms. One is the Prim's algorithm and the second one is the Kruskal's algorithm. Now these two are very important algorithms to learn in minimum spanning tree, and we will discuss them. So now we know what is a minimum cost spanning tree, and obviously these two will use the greedy approach This will use a greedy approach, and that's why Prim's algorithm is much similar to the Dijkstra's algorithm for shortest path. In the next tutorial, we are going to discuss the Prim's algorithm. So that's it for this tutorial. Thanks for watching.